Hey, what's up guys? It's Nicola from Calcunic, and today we're going to be talking about the product rule. Let's get right into it.
Alright, so the product rule is there to help us when we have a product of two functions and we want to find their derivative. So we have the derivative of two functions, say f of x and g of x, and the product rule tells us that this derivative is equal to f prime, or the derivative of f, times g of x plus f of x times g prime of x, or the derivative of g. So let's say we had a question like find the derivative of 2x plus 1 times 3x minus 5. And so in this case, we could identify the two functions. First, we'll start with the leftmost one, call it f of x, and this is 2x plus 1. And so the derivative of f of x is just 2. And then we have our second function, g of x, and it's equal to 3x minus 5. And the derivative of g of x is simply 3. And so we go on to solve our question now using the product rule. First we have f prime x times g of x, and that's 2 times 3x minus 5. And we add that to f of x times g prime x, or 2x plus 1 times 3. Now we want to simplify this a little bit, so we'll do 2 times 3 and 2 times negative 5. And then we get 2 times 3x is 6x, 2 times negative 5 is negative 10, and we add that to 3 times 2x and 3 times 1, which is 6x plus 3. And if we group like terms, we get our final answer, 12x minus 7. So let's say we're asked to find the derivative of 4x cubed plus 2 times x minus 7. And so once again, let's identify the two separate functions and find their derivatives. So we have f of x is in this case equal to 4x cubed plus 2. And the derivative of that, well, we have to use the power rule on the 4x cubed term. And by the power rule, the exponent gets multiplied in the coefficient. So we have 4 times 3, because the exponent in this case is 3. And we reduce the exponent by 1. So we have x to the power of 3 minus 1, or just in this case 2. And 2 is a constant, so the derivative is 0. And this is equal to 12x squared. And so here we have g of x is equal to x minus 7. And so this derivative is just equal to 1. And so putting this together, first we have f prime, in this case 12x squared, times g of x, so x minus 7. And then we're adding that to f of x, so 4x cubed plus 2, and then times 1, so we could just leave that out of the way. And now we want to simplify. We have 12x squared times x, so 12x cubed, and then 12x squared times minus 7, so minus 84x squared, and then we're adding 4x cubed plus 2. And if we group like terms, we get that the answer is 16x cubed minus 84x squared plus 2. Let's move on to some trigonometry now. So we have the derivative, in this case, of, let's say, x cubed times sine of x. And so our two functions, first we have f of x is equal to x cubed, and the derivative of x cubed by the power rule is 3x squared. And then we have our second function, g of x, is equal to sine x, and then g prime x, the derivative is equal to, well, the derivative of sine is just cosine x, so that's it. And then putting this together, we have that the derivative of x cubed times sine x is first f prime x, so 3x squared, times sine x, plus the f of x, so just x cubed, times g prime x, or in this case, cosine x. And we could group terms, like terms a little bit, and we can factor out a x squared term. And what's left is 3 sine x plus x times cosine x. Let's say we have a question like the derivative of tangent of x times sine of x. And so we have our two separate functions first. F of x is tangent of x, and the derivative of that, derivative of tan, is secant squared of x. And so here we have g of x is equal to sine x, and the derivative of sine x is just cosine x. So we have that the derivative of this is going to be the derivative of tan, so secant squared of x times sine x, then plus tan x times the derivative of sine, so just cosine x. And we could actually reduce this a little bit because tangent is known to be sine over cosine. And so we're going to have here, same as before, secant squared of x times sine x. But now we have sine x over cosine of x, which is tangent, times the cosine of x. And it's pretty clear here that we can reduce the cosines and leave us just with sine. And then if we choose to factor out a sine, we can get our final answer really neatly. We have sine times secant squared of x, and the sine term is grouped already here. And then on the right hand side, we already have the sine x factored out, so all that's left is 1. And that's our final answer. Let's try some examples using the natural logarithm and e. So if we have the derivative of e to the x times 4x cubed minus 1. So now we have f of x, which is just e to the x, and this is probably the easiest derivative to remember because it stays exactly the same. The derivative is still e to the x. And then we have g of x is equal to 4x cubed minus 1, and this derivative by the power rule is 12x squared. And so we have the derivative of this is going to be the derivative of e to the x, which is just e to the x, times 4x cubed minus 1, plus, again, e to the x times the derivative of 4x cubed minus 1, so 12x squared. And we could choose to factor out an e to the x term, so we get e to the x times 4x cubed plus 12x minus 1. Now suppose we're asked to find the derivative of ln x times sine x. And so we have f of x is equal to ln x, and the derivative of the natural logarithm is just 1 over x. And then we have g of x is sine x, and we all know that the derivative of sine is just cosine x. And so then we're going to have that this is equal to 1 over x, the derivative of ln, times sine x, so 1 over x times sine x, times plus ln x times the derivative of sine, which is cosine x. And there we can't simplify any further, unfortunately, so here we have our final answer. So let's try one last question. We're asked to find the derivative of x squared times cosine x times 2x plus 5. And so now we have a product of 3 separate functions, and our current product rule doesn't suffice for this. There is actually a product rule for 3 functions, but we noticed that we could actually just multiply these 2 functions together and get a simple 1 function. And so if we do that to the side, we have that x squared times 2x is 2x cubed, and then x squared times 5 plus 5x squared. And so this becomes the derivative of 2x cubed plus 5x squared all times cosine x. So now we have our two separate functions. First we have f of x, which is equal to 2x cubed plus 5x squared. And this derivative is, first we have 2 times 3, so 6 times x squared. That's by the product rule, sorry, the power rule. And then we have 5 times 2, that's 10, times x to the power of 1, so we can just leave that empty. And then we have gx, g of x, which is in this case cosine x. And the derivative of cosine is negative sine x. Don't forget that negative sign. And so if we put this together, we have that the derivative is equal to f prime x, in this case 6x squared plus 10x times cosine x. And this is plus f of x, so 2x cubed plus 5x squared times negative sine x. And we see that we could factor out a term of x, so we'll do that. We have x all the way in front times 6x plus 10 times cosine x. And we could move the negative sign here to the front, and we'll have minus, remember we took out an x term, so we have minus 2x squared plus 5x times sine x. And that's our final answer.
Alright guys, thank you so much for watching. If you had any questions about the video or just other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you enjoyed the video, if you learned something, drop a like and subscribe. It really helps me grow my channel, reach a greater audience, and hopefully help more people with math. That's all for me. Till next time.